Okay, we're going to look at when we've got the sum of arithmetic series, and obviously the questions we're going to look at are just going to involve those, but I'll talk about how you decide what formulas to use. The good news is these are given in the formula book, but it's about knowing when to use them, and we'll show where they come from. So S of n is the sum of all your terms, so it's a plus d plus a plus 2d and so on, all the way up to your last term, a plus n minus 1d. I've just written it as L here, and you'll see why. To get what the formula is, imagine rewriting this but the other way around, so starting with the last term and going to the first. And then when I add them together in pairs, what I get a plus L plus all the way up to the end, a plus L. Well, all that is n lots of a plus L. I've got that pair of terms appearing n times, so I can write it n lots of a plus L. So that's two lots of the sum because I've added them together, I've done that plus that. So our S of n can be written as n over 2 a plus L. Or I can substitute from what I did in the previous video, the last term is a plus n minus 1d. I can write it as n over 2 2a, because I'm adding on to that one there, plus n minus 1d. There we go. Now, all in all then, I've got four formulas. Three are given in the formula book, and my general term that I like to use. So, either way around, you can consider, does the question involve the sum, does it involve the last term? If it involves the sum and the last term, I use Sn equals n over 2a plus L. If it involves the sum but not the last term, I use Sn equals n over 2, 2a plus n minus 1d. If it doesn't involve the sum, and does involve the last term, hang on, I've got this the wrong way around, try again, and doesn't involve the last term, I use the general term, uk equals a plus k minus 1d, doesn't involve the sum but does involve the last term, and use L equals a plus n minus 1d. And I'm going to be referring to that as I do my examples. So, for example, number 1, we're given Sn equals 4, plus 4 and 2/3, plus 5 1/3, and so on. So I know what a is, I know what d is, but I do not know the last term, and I want S of 100, so I'm using the 1 without the last term. I'm going to be using n over 2, 2a plus n minus 1d. So 100 over 2, 2a, 8, plus n minus 1, which is 99 times 2/3 is my difference. So 99 times 2/3 is 66, add 8, 74, so it's 50 times 74, or 100 times 37, 3,700. Okay, so it's quoting the formula, sticking the numbers in, pressing buttons, working out the answer, but choosing which one to use there. Second example, Sn equals 10 plus 7 plus ... down to minus 47 and minus 50. So I know that d is minus 3, a is 10, but I also know the last term is minus 50. And asked for the sum of the first 10 terms again, so I'm going to be using n over 2 a plus L. Use whatever's appropriate in this case here. So the only difference here is, what I don't know what n is. I know what the first term is, I know what the last term is, so I'll have to do what I did before to actually work out what n is. So I'm going to use L equals a 10 plus n minus 1 times minus 3, and that's going to end up being minus 50, and I'm going to solve that. So n minus 1 equals minus 50 minus 10, minus 60 over minus 3, 20, n equals 21. I can now go back to say Sn equals 21 over 2, a 10 minus 50. So 10 minus 50 minus 40, divided by 2, minus 20, so 21 times 20 is minus 420. That's my sum of the first 21 terms. I should have written S21 there, like that. Okay? A few more examples then. We've got sigma notation, because obviously I can use the sigma notation in exactly the same way as before. I could expand this if I wanted to by putting r equals 1 in to get 3 plus 4, 7, r equals 2 in, 11, it's going up in 4s, that's what the 4r does, and then all the way to 40 times 4, 160 plus 163. I could do that. So I've got enough here. I know what the first term is 7, I know what the last term is 163, I know that n is 40 in this case here. So I can do Sn equals n over 2 a plus l equals 40 over 2, 20, 7 plus 163, 170, 170 times 20, 1700, 3400. Okay, so press button and get your answer. Now, as mentioned in the previous video, example 4, they give me the value of the 10th term is 23. The sum of the first 7, which is 56. I can't fudge this. I have to use Y10 equals a plus 9d, which is 23, and S7, which is 7 over 2, 2a plus n minus 1 6d, which is 56, and turn these into simultaneous equations. So I've got the first one is there, a plus 9d is 23, and rewrite this, 56 over 7 is 8, I can divide by 2 to get a plus 3d equals 8, and a plus 9d equals 23. And I'm hopefully good to go here, subtracting 6d equals 15, d equals 2.5, and sub that in 7.5, a equals a minus 7.5, 0.5. Okay, check it, 9 lots of that, yep, 23, we're all good to go. So notice I have to do simultaneous equations. There's no way of fudging between a term and a sum. So that's why what I did before about my general term is a good thing to do. Example 5 then, it asks for the sum of the 20th to the 30th inclusive. It's given me the series of 6 plus 15 plus 24 and so on, so it's going up in 9s and starts at 6. I know what the n's are. I'm going to use n is 30 to get the sum of the first 30, but I'm also going to do the sum of the first 19, so I include the 20th when the difference, so the ones that, so it's from 1 to 19 aren't included, but the 20 to the 30th is. So I'm going to be doing S30 then, so it's 30 over 2, 2a at 12 plus 29 times 9, and then minus 19 over 2 at 12 plus 18 times 9. And press button to get my answer. 15 bracket 12 plus 29 times 9 minus 19 divided by 2 times bracket 12 plus 18 times 9 close brackets equals 2442. Okay, so notice because it's inclusive, I have to be quite careful as to what it's not S30 minus S20, it's S30 minus S19. That's the only big thing there. I've got a couple more to do. Let's have a look at what they are. I've got them on my sheet here, so I'm going to clear all this off for now, and let's have a look at example 6, which says I've got a series 5, I have 13, I have 21, and I've got to go, so the sum is bigger than 3,000. So what's the end term that gives me just over 3,000? So I'm going to solve Sn equals 3,000, get an n value, and round it up no matter what it is. There's a possibility that I'm going to end up with a quadratic equation, 2 solutions. So let's have a look at what happens then. So Sn 3,000. I don't know the last term, so I'm going to be doing n over 2, 2a plus n minus 1 times 8, and expand that then. So I'm going to get 8n minus 8 plus 10 plus 2, divide by 2, 4n and plus 1, so 4n squared plus n, and then minus 3,000 equals 0. I might as well, because I'm feeling particularly lazy today, go to my solve, number 2 polynomial, degree 2, and I've got 4n squared, I've got 1n, and I've got minus 3,000. The minus means I'm going to end up with a positive value for n and a negative value for n. Obviously, my answer then, n equals 27.2 something or other, and n is minus 27.5. So n has to be the 28th term. It has to be a positive value, and that's the first one that gets my sum over 3,000. Okay, so yet again, nothing wrong with using your calculators as appropriate. And the last one here, quite a nice one. They're given us a quadratic formula for Sn, and it just wants the first three terms. So, well, it's quite straightforward. I stick n is 1 in. S1 is the first term, so it's 3 plus 4, which is 7. There we go, nice and straightforward. Stick n is 2 in, and I get 3 times 4, 12, plus 8, Sn equals 20. I should have written so it's S2. Well, that's the first term A, and then the second term A plus D. Well, if the first term is 7, and the sum of the first two is 20, my second term, I should have written U2 for that one, really, shouldn't I? It's 13. And that gives me a sum of 20. N equals 3. Well, I can ask him a pattern really, because it's an arithmetic, it's 7 then 13. Hopefully U3 is going to be 19. I'm going to check it because I'm expecting this S3 to be 3 times 9, 27, plus 12, 39. Well, if that's 7 and that's 13, that's 19, the other 39, there's my first three terms in. Okay, I know it's in arithmetic, I know it's going up in sixes, so once I've got the first one and the second one, I can give you the third one, I can tell you the fourth is 25 and so on, the fifth is 31 and so on. So just stick numbers in. You're not going to be asked to do this really for the first 20 terms, only for the first handful like that. And that's it.